And so today we're going to start with how do we deal with three sets? What does that Venn diagram look like? And then also we have all of these set operations. You can perform different operations and you could ultimately be talking about the same regions in those Venn diagrams. So we're going to go through and figure out how can we verify that two sets are equal or not. So first, let's take a look at a Venn diagram with three sets. Okay. So we've got our universal set U, and we have three sets inside of it. So I'll call this set A. Then I'll do another circle, which we'll call set B. And then a third circle, which we'll call set C. Make this one green. Try to make it somewhat spaced out. Make this a little bigger. If I can. There we go. That's much better. Okay. So we've got our three sets, and ultimately this breaks it apart into different regions. So your book is going to use Roman numerals. That's what you're going to see on all of your homework questions. This is region 1, region 2, region 3, 4, 5, 6, 7, and then the outside is considered section 8. I'm going to use numbers a lot though, because it really doesn't make a difference, but what goes in each of these regions is going to be specific. So we're going to talk about a couple of them. Like this middle one's not too bad. It's what's in common to all of those. Here, these are the elements that are unique to A. These are the elements unique to B, unique to C. So you have different ways to actually write those sets, but we'll just kind of look at a few in particular. So I'm going to duplicate this whole thing and shrink it down. And we're going to look at three regions in particular. Okay. So the first region is the one smack dab in the middle, which is region 5. Okay. And this one's not too bad to actually write in terms of sets. It's the elements that are in common. So it's what's in their intersection. So it's set A intersected with set B, intersected with set C. So the elements here are in A, B, and C. So it's in every single set. Okay. So that one's not too bad to write in terms of the sets. Same thing, this doesn't really have a specific number. It's regions 1 through 7. But I can talk about this shaded area in terms of set notations. So this is what's in any of the sets. So we've joined them all together. It's A union B union C. So the elements here are in A, B, or C. Okay. And the reason I actually did this one is because you see there's only one thing left on the outside. That would be the complement of this set. It's everything outside of it. So region 8 is the complement of this one. So if I want all of this lovely area outside of here, which I'm going to poorly color in for now, and I'll go back and make it look nicer for your actual notes. Okay. Region 8 is everything not in A, B, or C. So it is the complement. Okay. So that's the complement of A, B, A union B union C. So i.e., these are elements not in A, B, or C. Okay. So when you're building a Venn diagram with three sets, you're going to do the same thing that you would do with two sets. Start right smack dab in the middle, find the elements that are in common, and then just kind of go set by set. So let's try an example. We're going to construct a Venn diagram illustrating the following sets. So our universal set is every single element in this topic of discussion. And so I have picked a bunch of Disney movies, some classics. We got Bambi, Cinderella, Dumbo, Frozen, Hercules, Mulan, Pocahontas, Tangled, Tarzan, and Up. Okay. So these are all of the movies in our discussion. And now we've got 3 subsets of this. So set A contains the movies Bambi, Hercules, Pocahontas, and Tarzan. Set B contains the movies Bambi, Hercules, Mulan, and Tangled. And then our third and final set contains Bambi as well, Frozen, Pocahontas, and Tangled. Okay. All right. So try to keep all of these in view simultaneously. We have our giant universal set. So I'm going to try to make this as big as I possibly can. Let's see. I'm going to take up the whole page pretty much. My screen doesn't really allow me to turn it sideways, but let's see. Nope, that doesn't. Should be good though. Okay. So here is our universal set. And then I've got these 3 sets inside of it. I've got to make these large enough to be able to fit movies. Some long titles. I'll make this one set A. This will be set B. And then set C will go right down here. Make it more ovally if I can. No, can't. That's fine. We'll make this work. Okay. So we want to start with the elements that all of these have in common. I can zoom in a tad bit. And so if we look, good old Bambi is in all of these sets. That tells us Bambi should go right here, smack dab in the middle. Okay. As that is the only movie that's in common to all 3 of these sets. And so I'm also going to cross that out of my universal set since I've gone ahead and used it. Okay. Now you can kind of pick and choose. Let's go ahead and go to, let's see, what color can I use? Let's work in this region here. So these would be the elements that are in common to just A and B. So we want to see if there's any overlap between A and B only. And so if we look at these 2 sets, A has the movie Hercules, and so does B. So Hercules belongs right here in region 2. Okay. Now let's move to another region that overlaps between these. Let's see what A and C have in common. So hard to color in here. Okay. So if I look at sets A and C, they both have the movie Pocahontas in common. So Pocahontas is going to go in this region, which is just the overlap of A and C. There we go. And then finally, let's do our last overlap. And that is going to be what's in common between B and C. And so if we look at these two sets, B and C have the movie Tangled in common. So Tangled goes right here in this region. Okay. Now I can go to what's unique to each set. And so right here, let's make this an even bigger, make my coloring a lot easier. Right here are the elements that are unique to set A. And there is one movie that is only in set A, and that is good old Tarzan. So Tarzan belongs right here. Moving on to set B, the only element that is unique to set B is Mulan. So Mulan is going to go right in this region. And now we've gone and used Mulan. And I should go ahead and mark out. We have used Pocahontas, we've used Tangled, we've used Tarzan, we've used Hercules, we've used Mulan. And then finally, I have one more element remaining in set C, and the one that is unique to C is Frozen. So now we're going to use up this one, and that means we've used Frozen as well. Okay. So we still have 3 elements in our universal set that have not been used. We've got Cinderella, Dumbo, and Up. So those just go outside, and you can put them wherever you want. So I'll just put them right down here. Cinderella. You can put another one over here if you want, Dumbo. And then you can put Up wherever. Okay. But this is our Venn diagram for these 3 different sets. All right. So now what happens though if we don't know what's actually inside of each of these regions? And I try to perform a bunch of different set operations. What we're going to do is we're going to use Venn diagrams to determine if the following statements are equal. Or to determine if the following sets are equal. For all sets A, B, and C. Okay. And so I've got 3 sets. I have no idea what's inside of them. It has to hold for every single set. So no matter what I put in any of these, the 2 must be the same. So we want to see if A union B intersect C is equal to A union B intersect A union C. So this is a problem. I have a lot going on. I have a lot of pieces of information. What I want to do is I want to draw our Venn diagram with 3 sets. So we've got our universal set, we have set A, we have set B, and we have set C. And it splits it into 7 regions. So I'm going to use numbers 1, 2, 3, 4, 5, 6, 7, 8. Okay. Just like at the very beginning back here, region 5 can be represented by this set. Region 8 can be represented by this set. What I want to do is figure out with these operations, which region or regions are we talking about? So if I find the elements in A union B intersect C, am I taking up 1, 2, and 3 maybe only? Maybe 5's in there? I don't know. I want to figure out the areas I'm ultimately talking about. Then I'm going to do exactly the same, figure out the areas that represent this set. If they're talking about the same region, or if they talk about the same region, they're going to be the same set. So they'll have exactly the same elements inside. So the first thing we're going to do, or step one, is we're going to find the regions in A union B intersects C. 1 second. So the best way I think you can possibly do this is with a chart. So let's look at the set, and that's going to tell us what regions fall within that specific set. Okay. So you've got to do two things. Before I can work with this intersection or union, I've got to find what's in A and what's in here in B intersects C. So you kind of work from the inside out. Find the stuff inside parentheses first, and then worry about the other operations. So I'm going to start inside the parentheses. We're going to look at what regions is inside B intersects C. So this is where these two overlap. And so I'm looking, where does circle C overlap with circle B? That would be talking about regions 5 and 6. So anything inside 5 and 6 would go inside the set. Okay. Now I want to look at set A. And so I want to look at all of the regions that are inside set A, which is 1, 2, 4, and 5. Okay. Now I've got to deal with this union operation. So I want to merge these two sets together, which means I merge those regions. So 5 and 6 were in B intersects C. I'm going to merge all of these together. So the region that's in A union B intersects C would be 1, 2, 4, 5, and 6. So this would be the regions this operation talks about. Okay. And so off to the side, I'm going to go ahead and highlight that just so we see it all. Everything in here along with 6. Okay. Now I'm going to do exactly the same thing with the second set. I'm going to go ahead and find the regions in A union B intersect A union C. Okay. And I'm going to bring this down here so I can keep track a little bit easier. So we want to look at the set and we want to see what regions fall in there. Same thing. Okay. So I'm going to start with A union B. Let's find what's in those two. So this melds A and B together. So anything that's in one of these circles is in their union. So A union B talks about 1, 2, 3, 4, 5, and 6. Then I look at A union C. And this is anything that falls inside circle A or circle C. So this set would take anything in regions 1, 2, 4, 5, 6, or 7. Okay. And now I go ahead and I take the intersection of these two. So I want the stuff that's in common. So here is A union B. I want all the stuff that is in common to these two. So that would be region 1, region 2, region 4, region 5, and region 6. Okay. So ultimately, this is talking about 1, 2, 4, 5, and 6. Okay. So regardless of what elements fall in here, after you draw your Venn diagram, these two talk about exactly the same area. So even though they look completely different, they're really the same thing. So notice 1, 2, 4, 5, and 6, 1, 2, 4, 5, and 6. Since each sets talk about the same region, where each set represents the same region, we can say these sets are equal. So yes, it is indeed true that A union B intersects C is equal to A union B intersect A union C. Okay. So this is what you're going to do each and every time. You're going to go ahead and you're going to find the specific regions, go through the sets themselves. Just think of it that these numbers are representing everything within that region. So if you have the same numbers at the very end, you're good. Those sets are going to be equal. Okay. So let's try a second one so we can see what happens when sets aren't going to be equal. So the second one we're going to do is A union B intersects C complement. We want to see if that's equal to A complement intersect B complement union C. Okay. I'm going to cheat. I'm going to copy and paste this region, and I'm going to go ahead and copy and paste these as well. So I'm going to need two of them. Okay. So first thing I'm going to do is look at the first set that I'm given. It doesn't really matter which one you pick to do. So I'm going to make a chart that's going to talk about the region A union B intersects C complement. So we'll make a chart with the sets and then the regions it talks about. Okay. So let's start with what's inside the parenthesis. I've got to find B intersects C. So that will be 5 and 6. Now we need the complement of this. So remember, you work inside parentheses, then you do exponents next. So your complement's going to come next. So that tells me I take everything except 5 and 6. So it would be everything around here, not those two. So this will be 1. Oh, make this a little smaller, so don't remove that. That will be 1, 2, 3, 4, not 5 or 6, but 7 and 8. Okay. Now I'm going to take the union of this with set A, so I might as well find the stuff that's in set A. So looking at set A, that's the numbers 1, 2, 4, and 5. And now we're going to merge these two sets together. So we're going to take A and we're going to union it with B intersects C complement. So I'm going to take A and I'm going to meld it with everything except 5 and 6. So when I merge these two sets together, I'm combining this and this. That's giving us 1, 2, 3, 4, 5, 7, and 8. As long as it's in 1, it's in that union. So I'm pretty much talking about everything except region 6 in this set. Okay. Now we're going to do the same thing with the other set. A complement intersect B complement union C. Okay. And so we're going to look at the set and the regions we're talking about. So we've got a lot we've got to kind of find here. Again, I'm going to start inside parentheses. Before I can do this union, though, I've got to find B complement. So let's look at that set first. So this is everything not in B. So I'm going to take everything outside of B. So that would be regions 1, 4, 7, and 8. Okay. Now I'm going to combine that with region C. So you can put region C if you want down here. That's going to be everything inside this circle. So that's regions 4, 5, 6, and 7. And now we merge these two together. So I'm going to take that and combine it with B complement. So pretty much I'm going to get everything except regions 2 and 3. So we're going to meld these together. So B complement union C is going to be 1, 4, 5, 6, 7, and 8. Everything but 2 and 3. Okay. Now I move on, and I'm going to find the intersection with A complement. So I got to find A complement. That is everything not in a circle. So that will be regions 3, 6, 7, and 8. Okay. And so we are almost there. I've got A complement, I've got B complement union C. We're going to look at the overlap of these two sets. Okay. And so if I look at B complement union C, see that in a different color on here, that's regions 1, 4, 5, 6, 7, and 8. So 1, 4, 5, 6, 7, and 8. Okay. And I want the overlap of these regions. So they have 6 in common, they have 7 in common, they have 8 in common. So their intersection talks about regions 6, 7, and 8 only. So ultimately, we are not talking about the same regions. These two are not the same thing. So we don't end up with the same region. So these are not equal. So what you can say is A union B intersect C complement is not the same as A complement intersect B complement union C. Okay. All right. So this leads to actually start of one of our cool laws that we have that kind of has an equivalent when we start talking about logic in the next chapter. And it's something known as DeMorgans Laws. So ultimately, this kind of gives you another way to talk about equivalent sets, or kind of how operations can distribute among different things. And so you're going to see the same type of thing again in the next chapter. But this is called DeMorgans Laws for sets. And so what this tells you is if you're taking the union of two sets and you want its complement, using your Venn diagrams, you can figure out what regions this talks about, and you'll be able to see it's exactly the same as you can distribute that complement down. So you get the complement of each set, but the operation has to change. So it flips from a union to an intersection. Or if you have an intersection in the middle and you want to take the complement, you distribute the complement and the symbol has to flip. Okay. So I'm going to show you an example of this in two different ways. We're going to look at two sets. We're going to use DeMorgans Law, and then we're going to use Venn diagrams. Okay. Now, realistically, you can kind of do whichever method you want, but you don't want to throw this law completely out of your mind. So you're definitely going to see it pop up in some way or another. So let's let our universal set U contain the letters A through J. So A, B, C, D, E, F, G, H, I, J. Set A is going to contain A, E, G, H, and I. And set B is going to contain A, G, I, J. Okay. And we're going to find A union B complement. Okay. So the first thing I'm going to do, my method 1, got something on my screen, sorry. I'm going to do this before I draw a Venn diagram. I'm going to use DeMorgans Laws. Okay. If I want to find A union B complement, it's the same thing as A complement intersect B complement. So pretty much if I just find these two sets, then I take what's in common to the two. So let's find A complement. I've got set A. I want everything in my universal set not in A. So we would not include A, E, G, H, or I. So A complement would be B, C, E, F, and J. Okay. Not E, T. Can't read. Okay. So I don't include A. I don't include E. I don't include G, I don't include H, I don't include I. So those are going to be the letters that remain. Now I'm going to do the same thing. I'm going to find B complement. So I go ahead and cross out the stuff that's in B. So I don't include A, I don't include G, I, or J. So what's left over is B, C, D, E, F, and H. Okay. All right. Now I go ahead and take what's in common to these two. So I want A complement intersect B complement. And what's in common is letters B, C, D, and F. Okay. So A union B complement is exactly equal to B, C, D, and F, without me needing to draw a Venn diagram. Now, realistically, if you wanted to use a Venn diagram, that's perfectly fine. I'm going to go ahead and copy these down here so I can kind of cross stuff up a lot easier. Okay. So here is set A, here is set B, and our universal set out here. So I got to start with the stuff that's in common. They both have A, G, and I in common. So that goes right in the middle. Then what's unique to A is E and H. We'll color code these two, make it a little easier for you. So A, G, and I are in the middle. Next, we've got E and H on their own. So that goes just in set A. And then common, or what's unique to set B is letter J. So we've used A, E, G, H, I, J. So the stuff that goes on the outside then is B, C, D, and F. Okay. And so our set A union B complement means elements not in A union B. Okay. So the union joins these two circles. The complement then is everything outside. So from our Venn diagram, A union B complement is B, C, D, and F. Okay. So you see, regardless of the method you picked, you end up with exactly the same thing. So they both work. Personal preference, really what you use. You don't want to throw this law completely out of your mind because, again, I'm going to ask you it in some way, shape, or form. So you want to make sure you know what that statement actually is. Okay. All right. So the last example that I have in this section, now that we've got a little more practice kind of working with these multiple sets, is we're going to define the region define the given region using sets A, B, and C and set operations. Okay. So basically, we're going to talk about regions 1 through 8, and we're going to try to figure out how to write those out. And so I'm going to do 2 examples. I think the best thing you can possibly do is really write it in words first, and then that kind of translates to those operations. So here is set A. Then we've got set B. And then set C down here. And the first region we're going to talk about, let me write the numbers in here. This is region 1, 2, 3, 4, 5, 6, 7, and 8. We're going to first start out talking about region 7. So let's talk about a description. If you were to talk about the elements in here, it's in the overlap of sets B and C. So these are elements in B and C, but I'm ignoring what's in A. So it's what's in common with B and C, getting rid of what's in A. So these are elements in B and C, but are not in A. Okay. And ultimately, that would mean if they're not in A, they're in A complement. So they're not in A. That represents the set A complement. But they are in B and C. So the way we could replace this, they are elements in B and C and are not in A. So then I can completely translate this set. So they're in B and C. That would mean our union or intersection. They're in B and C. So they're inside this set and they're not in A. So the word and translates to the intersection, and not in A translates to our complement. So you pretty much create a sentence with it. Now, there's not one right answer for this. Another choice you could pick, they're in the intersection of these two. So I take what's in common to B and C, but then I have to delete what's in A. So another choice would be I take the intersection of those two and then I delete what's in A. Okay. So there's a lot of different ways you can go about these problems. Let's try a different one though to get more practice. Let's talk about region 1. And again, I'm going to write a description to try to translate that to a sentence first. And you can see you might need to rework how you described it. Because what I did at first, I put that but the but also means, okay, it's doing this thing and it's also doing this thing. Okay. So for my description, these elements are definitely in set A. But I'm not taking everything from set A. I'm getting rid of stuff that's in B or C. So they're elements in A and they're not in B or C. So it's unique to A. Okay. So translating that to words, they're in A. So I go ahead and take set A. And tells me I take an intersection. And then not in B or C would mean I take the complement of B or C. So B or C is the union, and I want to take the complement. Or applying DeMorgans laws, you can think of this as A intersect with the complement of B intersect with the complement of C. So it's not in A, it's not in B, and it's not in C. Or it's in A, not in B, not in C. Okay, either one is good. And then another choice you could do is from A, you're deleting what's in B or C. So you're deleting the stuff in B and C. So either one of these, perfectly fine. They both represent the same thing.